Every year, humanity discards more than 10 million tons of electronic waste. Of this, hundreds of thousands of tons are televisions, packed with precious metals, complex plastics, and even deadly toxic substances. But what happens to them after they leave our homes? Did you know that inside one old, bulky television set lies pure gold, silver, and components that could become the heart of new gadgets? This isn't just recycling. This is a high-tech treasure hunt. Today, we'll show you how the most advanced recycling facilities operate and why this process matters more than you might think. It all starts not at the factory, but in our homes and offices. Old, outdated devices are collected at specialized reception stations. In developed countries, this is a well-oiled system, from dedicated containers in supermarkets to trade-in programs run by major retailers. Modern recycling centers aren't grim rubbish tips, but gleaming high-tech facilities. Their primary goal is to extract all reusable materials as efficiently as possible, while safely neutralizing the toxic components hidden inside. At large-scale operations, television recycling is organized along automated production lines, where most processes are carried out by machines rather than people. The first stage at the facility is the medical examination and sorting. Televisions are separated into three main categories: bulky cathode ray tube monsters from the past, slimmer plasma panels, and modern liquid crystal displays. Each type requires its own entirely unique approach. Then the undressing begins. Robotic manipulators or workers strip away the plastic casings. This plastic is immediately sent to giant shredders where it's ground into tiny fragments which, after remelting, will become parts for new motor cars or casings for other electronics. Metal frames and fixings are also separated and sent to their own recycling line. Once the casing is removed, the defenseless innards of the television move on to the dismantling line. Old cathode ray tube televisions receive particular attention. They can genuinely be described as environmental dirty bombs. The most hazardous component is the cathode ray tube itself. It contains up to several kilograms of lead, which was used to prevent X-ray radiation, whilst the internal surface is coated with a layer of phosphor containing toxic rare earth metals. Consequently, they're dismantled with exceptional care, often by hand, within sealed chambers. First, a specialized heated wire or laser carefully separates the front clean glass from the rear lead-laden funnel. The glass is then cleaned, crushed, and sent for recycling, whilst the lead is extracted for manufacturing new batteries. Modern liquid crystal displays are no less hazardous. Hidden along the edges of the panel, thin as spaghetti, are fluorescent backlight tubes. Each of these tubes contains a small but highly dangerous amount of mercury. That's why LCD panels are dismantled in specially sealed boxes with powerful ventilation systems. Robotic arms or workers in protective suits carefully extract these tubes. They're placed in hermetically sealed containers and sent to specialized facilities where the mercury is safely extracted and purified for reuse. The liquid crystals sandwiched between the glass layers present another challenging component. They're extracted using chemical solvents. Plasma panels require their own approach. Unlike LCD displays, they don't contain mercury, but their cells use inert gases such as xenon and neon. The panels are dismantled, the gases are collected in special containers for reuse, whilst the high-quality glass that makes up the screen is crushed and purified. Once the screens and casings have been neutralized and sent on their separate ways, the most valuable parts remain on the conveyor belt, the circuit boards. This is where the precious metals are hidden. Copper wires, aluminum heat sinks, and other metallic components are separated and sent off for smelting. The most important and complex part is processing the printed circuit boards. It's in these boards, within the microchips and connectors, that you'll find microscopic yet incredibly valuable quantities of gold, silver, palladium, and other precious metals. First, the boards are shredded into fine particles. These particles are then sent to the chemical workshops. The most common extraction method is chemical leaching. The shredded boards are immersed in special acid solutions. To extract gold, they often use aqua regia, a mixture of concentrated hydrochloric and nitric acids, which can dissolve even this noble metal. After the precious metals have dissolved into the solution, the precipitation process begins. Special chemical substances are added to the liquid, which cause the pure metals to fall out as sediment. For instance, ferrous sulfate is used to precipitate gold. This gold sediment is then thoroughly washed, dried, and remelted into small but incredibly valuable ingots. Similar methods are employed to extract copper and silver, though using different, less aggressive acids or the electrolysis method. In the final stage, all the recovered materials, gold, copper, aluminum, glass, and plastic, are compressed into compact blocks. Each year, millions upon millions of televisions are discarded worldwide, with their combined weight running into millions of tons. In Europe alone, for instance, electronic waste exceeds 10 million tons annually, and a substantial portion of that comprises televisions and monitors. This staggering figure isn't merely a statistic, it's testament to our rapid technological advancement and its darker consequences. But there is encouraging news. Year on year, growing numbers of people are recognizing the importance of proper disposal. Hundreds of thousands of tons of old televisions now find their way to recycling facilities each year, helping us preserve our air, water, and finite natural resources. Here's what the real secret we mentioned at the beginning is all about. Your old television isn't rubbish, it's a genuine urban mine. A single ton of old circuit boards contains 40 to 50 times more gold than a ton of gold ore extracted from a traditional mine. Electronics recycling isn't simply about caring for the environment, it's an incredibly profitable business of the future. We've learned to extract the most valuable resources not from beneath the ground, but from what we ourselves have created and discarded. And every time you take an old television for recycling, you're not just getting rid of clutter. You're returning precious metals to the economy and helping to make our world a bit cleaner.
Every year, the world produces over 20 million tons of mineral wool, with nearly half of that volume coming from the United States. This is a material capable of withstanding direct flame contact at temperatures of 1,500 degrees Celsius, whilst weighing less than the air trapped inside it. How does solid, heavy volcanic rock, born in the Earth's fire, become a light and fluffy insulator resembling delicate candy floss? How have engineers harnessed fire powerful enough to melt stone to create silence and warmth in our homes? And most importantly, what secret do these enormous factories hide as they transform tons of dirty industrial waste into a clean and safe product for the future? Watch until the end, because what follows is a fact that will forever change your perception of this remarkable stone fleece.
The mineral wool market in the United States is a colossal, invisible machine, churning billions of pounds. We're talking about an industry worth over 4 billion pounds per year. And according to analysts' forecasts, it's only set to grow. This means that right across the country, from the frozen forests of Minnesota to the scorching deserts of Arizona, more and more builders and homeowners are choosing this rock-based jumper for their walls, roofs, and floors. But the story of this material doesn't begin in a factory. It starts deep within the Earth's crust, in the thunderous heart of a quarry. The foundation of it all is basalt. This is a dark, dense volcanic rock, the very material that forms the ocean floor, and which millions of years ago erupted from volcanic vents. But alongside it comes a rather unexpected partner: slag. This is a byproduct from metallurgical giants, a solidified melt of impurities left behind after steel smelting. Once considered worthless waste and simply carted off to landfills, creating entire man-made mountains, today it's invaluable raw material.
Right then, picture the recipe for this industrial marvel. Take several portions of prime crushed basalt for strength, add a touch of slag to achieve the desired chemical properties, and for eco-friendliness and energy savings, generously season it all with recycled glass and offcuts of old mineral wool. All these stony ingredients arrive at the factory in enormous lorries and get tipped into a giant hopper. And now the real inferno begins, quite literally. From the hopper, this mixture, called the charge, flows continuously into an enormous vertical tower, a cupola furnace, or what's known as a cupola. It's a genuine miniature volcano created by human hands. Here, rather like feeding an insatiable maw, they load our stone mixture in layers, along with coke, a special fuel derived from coal that burns with incredibly high and stable heat. Massive fans, roaring like aircraft turbines, pump thousands of cubic meters of air into the furnace, driving the temperature up to absolutely astronomical levels, 1,500 degrees Celsius.
At such temperatures, the stone hasn't got a chance. It melts, cracks, and transforms into a liquid mass glowing an incandescent white. This river of fire flows out of the furnace along a special channel lined with fire brick. The sight is absolutely mesmerizing. A brilliant, blinding stream of molten stone radiating such intense heat that one simply cannot stand nearby without proper protection. And here, at the exit from this inferno, a genuine miracle occurs. The transformation of heavy, viscous liquid into light, airy fluff. This process is called fiber formation. Have you ever watched candy floss being made? A spinning center where sugar is poured in and fine threads that fly outwards. The principle here is exactly the same, but instead of sugar, molten stone, and instead of a small machine, a gigantic centrifuge. A thin stream of this stone lava hit several massive disks spinning at tremendous speed, making thousands of revolutions per minute.
When a droplet of molten rock strikes such a disk, the colossal centrifugal force instantly stretches it and flings it aside as an incredibly fine fiber, just a few microns thick. That's 10 times thinner than a human hair. Since this process occurs continuously, an entire cloud of red-hot stone threads
flies off the discs. It resembles a golden, luminous chaos. Billions of these finest fibers, cooling as they fly, transform into a light, wool-like mass. In just a moment, our heavy molten rock has become airy and fluffy. But for now, it's simply a formless cloud that needs to be gathered together. Whilst the fibers are still airborne inside a special chamber, a fine mist of binding agent is sprayed onto them from hundreds of nozzles. This is a special phenol formaldehyde resin that envelops each tiny fiber.
This cloud of glue-soaked fibers flies onwards and enters the settling chamber. At the bottom of this chamber sits a wide moving conveyor with a perforated belt. From beneath the belt, powerful fans extract air, creating a vacuum. This directed airflow pulls the fibers downward and lays them evenly onto the conveyor, forming a thick, fluffy carpet. This already resembles the future insulation, but it's still soft and the glue hasn't hardened yet. The thickness of this carpet is controlled by the conveyor's speed. The slower it moves, the thicker the layer that settles. And now this golden yellow fluffy carpet, reminiscent of a giant Swiss roll, is ready for the final stage, baking. It slowly enters an enormous oven known as a curing chamber. This is a long, multi-level tunnel maintained at a temperature of around 200 degrees Celsius. The purpose of this stage isn't merely to dry the carpet, but to bake the adhesive. Under heat, the resin polymerizes. That is, its molecules cross-link into a robust three-dimensional network, transforming into solid plastic that permanently bonds the stone fibers at their intersection points. It's within this oven that mineral wool acquires its final properties. It becomes resilient, capable of recovering its shape after compression. During this process, the resin often changes color, lending the finished product its characteristic yellowish-brown hue. From the other end of this gigantic toaster oven emerges no longer a loose carpet, but rather a solid, springy mat of specified thickness and density. However, it still remains an endless ribbon. Now it's time to transform it into a marketable product. This hot mat passes through an entire system of cutting tools. Sharp circular saws or powerful blades slice it lengthways and crossways with incredible precision into sheets or rolls of standard dimensions, for instance 16 or 24 inches wide, so they fit perfectly between the studs of a timber frame house. The edges are trimmed, and now we have the familiar product before us. And here, another bit of magic happens: packaging. The finished mats or rolls are fed onto the packaging line. A special press compresses them, removing nearly all the air. The product's volume can shrink several times over. Then this compressed block is quickly wrapped in robust polythene film and heat sealed. This is done to save an enormous amount of space during transport and storage. It's rather like a vacuum bag for clothes. Instead of a huge, fluffy roll, we end up with a dense, compact package. And when the builder on site cuts through the film, the mineral wool hisses as it draws in air and, like a spring, expands back to its original size within a matter of seconds. The finished packages are stacked onto pallets by robotic arms, wrapped in stretch film, and forklifts carry them off to the warehouse or straight into the back of a lorry. And so, as yet another lorry rolls out through the factory gates, our journey comes to an end. We followed how ordinary solid rock, having passed through the fiery heart of the furnace, became a high-tech cocoon that would preserve warmth, silence, and safety in someone's home for many decades to come.
Now for the most fascinating bit, the environmental credentials, because this is where mineral wool absolutely smashes expectations. We've already mentioned it's made from rock and slag. Well, here's the thing. On average, modern mineral wool contains 70% recycled materials. Sometimes that figure reaches as high as 90%. Just imagine, 3/4 of your insulation is essentially industrial waste that's been given a second life. We're talking about millions of tons of metallurgical slag that used to simply end up in landfills, now transformed into a high-tech product. It's one of the finest examples of a circular economy, where one industry's waste becomes another's treasure. Manufacturing giants like Rockwool or Owens Corning process so much slag each year, you could fill thousands of Olympic-sized swimming pools with it.
But that's not all. The second superpower is acoustics. Due to its dense, chaotic fiber structure, mineral wool is an incredible sound insulator. It doesn't just block sound, it absorbs it. When sound waves enter the material's depth, they're forced to navigate through a labyrinth of billions of stone fibers, losing their energy and fading away. That's precisely why it's beloved not only in residential homes for protection from noisy neighbors, but also in professional recording studios, cinemas, and even between floors to avoid hearing footsteps from above. It's like building a personal silent mode into your walls. And finally, the mystery promised at the beginning. Despite mineral wool appearing soft, each of its fibers is a microscopic stone needle. When working with it, these needles can cause mechanical skin irritation, that very itch. And whilst modern technology has made the fibers safer, this stone fluff will always remind you of its true, hard nature, demanding respect and caution.